Network architecture. Computer networks are usually developed to fulfill needs of their clients and users. Network architecture generally refers to design of computer network or communications network. It simply describes allocation task between all of computers and network. It is simply way in which all network devices and services are organized and managed to connect clients like laptops, tablets, servers, etc. And also how tasks are allocated to computer. It also facilitates system-level functionality, even robustness, extensibility, and evolvability. It is basically defined and described as physical and logical design of software, hardware, protocols, and media of data transmission. Classification of network based on use of computer nodes. Network architecture is classified into following categories. Two types of network architecture. Peer-to-peer network. Client-server network. Peer-to-peer network. In the P2P, peer-to-peer network, peers generally represent computer system. These peers are connected to each other with help of Internet. Files might be shared directly without requirement of central server among these systems on the network. It can be said that each of computers on P2P network usually becomes file server even as client also. In this architecture, system is generally decomposed into various computational nodes that contain the same and equivalent capabilities, abilities, and responsibilities. In this network, tasks are allocated at each and every device available on network. This network is very essential and important for small environments, usually up to at least 10 computers. There is also no separate division as clients and servers. Each and every computer in this network are treated same and equally and might send even receive message directly. This P2P network is generally useful in various fields such as business, education, military, etc. Advantages. Dedicated server or centralized is not very essential, so P2P network is less costly and is very cheaper. It is affordable. P2P is very simple and not complex. This is because all computers that are connected in network communication in an efficient and well-mannered with each other. It is very easy and simple to set up and manage, as installation and setup is less painless and computer manages itself. This is because of built-in support in modern operating systems. Disadvantages. Security is one of major issues in this type of network. This is because message that is sent flows freely among connected computers. If computer working with some of resources is down, and sharing of resources might become major problem. Performance, security, and access can also become major problem and headache with an increase in number of computers on this network. In the case of peer-to-peer network, it does not contain the centralized system. Therefore, it cannot back up the data as the data is different in different locations. It has a security issue as the device is managed itself. Client-server network. CSN, client-server network, is type of computer network in which one of centralized and powerful computers, commonly called as server, is hub to which many of personal computers that are less powerful or workstations, commonly known as clients, are connected. It is type of system where clients are connected to server to just share or use resources. These servers are generally considered as heart of system. This type of network is more stable and scalable as compared to P2P network. In this architecture, system is generally decomposed into client and server processor or processes. This architecture supports separation of functionality commonly based on concept of services. Advantages. A special network operating system, NOS, is provided by server to provide resources to many users that request them. It is also very easy and simple to set up and manage data updates. This is because data is generally stored in centralized manner on server. The server usually controls resources and data security. This network also boosts speed of sharing resources. If anyhow server goes down or crashes, entire will be affected by this. It is very expensive as compared to P2P. This is due to need for server with greater memory as well as need for many networking devices such as hubs, routers, switches, etc. Cost of NOS being provided is very high. A client-server network contains the centralized system. Therefore we can back up the data easily. A client-server network has a dedicated server that improves the overall performance of the whole system. Security is better in client-server network as a single server administers the shared resources. It also increases the speed of the sharing resources. Disadvantages. Client-server network is expensive as it requires the server with large memory. A server has a network operating system, NOS, to provide the resources to the clients, but the cost of NOS is very high. It requires a dedicated network administrator to manage all the resources. Servers. Typically computers with more processing speed, memory and hard disk space than a regular desktop computer. The network servers run their own operating system that manages the various network tasks as well as services that run on the network. Depending on the need for network storage and services, a single network may only use one or a large number of servers. Clients. Hardware devices which provide end users with access to data and services on the server. You can use these devices more or less independently. For example, you can open up software applications, create and edit documents and save files on the local storage medium, such as a hard disk. However, in a typical client-server network, a number of essential tasks are not performed by the client alone. Why are there different network architectures? Computer networks are built to serve the needs of their clients. Described below are three common types of enterprise networks. Access networks, for campuses and branches, are built to bring users and things on board, such as connecting employees within an office building. Networks for data center connect servers that host data and applications and make them available to users. Wide area networks, WANs, connect users to applications, sometimes over long distances, such as connecting hospital workers to health applications. These and all other networks face different security threats, which they need to guard against. To accommodate these varied requirements, all network types have unique architectures. Why are network architectures under pressure? Today, to serve the exacting needs brought on by technology advancements and digital transformation initiatives, networks are called on to do more. Access networks need to recognize, authenticate, and authorize user devices and smart things before bringing them on board. Data center networks need to connect applications in multiple data centers and clouds. WANs need to minimize costs and enhance user experience when serving distributed applications to distributed users. Networks also need to be dynamic, agile, and in lockstep with business needs. Traditional, manually intensive methods of managing computer networks are proving to be unsustainable. New approaches are necessary, ones that require transformational changes in how networks are architected. Components of modern network architectures. The industry is now using architectures that ease the burden of building and maintaining computer networks for the digital age. Only Cisco offers a complete portfolio of modern network architectures for access, WAN, data center, and cloud. Intent-based networking, IBAN. An intent-based network takes an organization's desired outcomes at a high level as input and sets up the network to achieve these objectives. It does so by automating operations extensively, analyzing network performance, pinpointing problematic areas, providing all-around security, and integrating with business processes. Controller-led. Network controllers are foundational to intent-based networking and are essential to scaling and securing networks in the digital era. Controllers dramatically simplify operations and help organizations respond rapidly to changing business requirements. They automate networking functions by translating business intent into device configurations, and they monitor the network devices continuously to help ensure performance and security. Multi-domain. Multiple networks in an enterprise communicate with one another through their controllers. Such cross-network, or multi-domain, integrations generally involve exchanging relevant operating parameters to help ensure that desired business outcomes that span networking domains are achieved. devices continuously to help ensure performance and security.